Today we begin Chapter 5, and we're going to be learning about algebraic expressions. What we'll learn today will focus on evaluating algebraic expressions, defining what a variable is, and then also writing an algebraic expression from a word problem situation. So let's get started with some vocabulary. As always, we want to take vocabulary down in our notes. A variable, which will be our first term, is a symbol that represents an unknown quantity. An algebraic expression, such as n plus 2, is an expression that contains variables, numbers, and at least one operation. So this right here, this n plus 2, that's an algebraic expression. And I'll abbreviate that with algex. Alright, so to evaluate an algebraic expression, we have to know a few things. So the branch of mathematics that involves expressions with variables is called algebra. This is what we're looking at today. In algebra, the multiplication sign is often omitted, meaning left out. So if we take a look at this expression here, 6d, or this term here, that means 6 times d. So if I knew what d was, I would do 6 times whatever that was. Now if I see the term 9st, that means I'm doing 9 times whatever s is times whatever t is. And also if I see mn, I know I'm doing m times whatever n is. And if I see an exponent, that means I'm actually going to evaluate it, such as a to the third as a times a times a. If it was a to the second, you just do a times a. Okay? The numerical factor of a multiplication expression that contains a variable is called a coefficient. So in the expression or the term 6d, 6 was the coefficient. So that was the number that was being multiplied by the variable. And an expression like y over 2, which can also be written as y divided by 2 or y multiplied 1/2, okay, then the coefficient would be 1/2. Alright, so let's get into our first example. Today we're just going to be evaluating algebraic expressions. We're not going to be solving for what the variable is equal to. No, we're actually going to be given what the variable is equal to. We're going to be evaluating the expression. So the expression I'm evaluating here is 3 times the quantity t minus 4. And I'm told that t is equal to 6. So all I have to do in this situation is plug this in and solve for what this entire expression is equal to. So in this case, this would be 3 times the quantity 6 minus 4. And now I need to think order of operations. Remember, that's PEMDAS. So we're going to do our parentheses first. So I'm going to have 3 multiplied by 2. So now all I have left is multiplication, so I can do 3 times 2 is 6. Final answer is 6. So when I evaluate this expression, 3 times the quantity t minus 4, it equals to 6. Let's try another one. So here we have an expression where there's 2 variables. 6s is minus 3t. And unlike this one here, where we had it was variable minus number and then all multiplied by number, we have number variable, number variable. So I have 6s minus 3t. I'm told that s is equal to 4 and t is equal to negative 2. So in this case, I have 6, and I have to remember back to what my first slide said. That means I'm multiplying by. So I have 6 times 4 minus 3 times negative 2. Now some of you might be saying, can't I just write this as this? With the dot? Certainly. Okay, you can also write it with parentheses, and there would be no problem with that as well. Okay, I'm going to leave it at just the times that I had before, just for neatness sake. So 6 times 4 I know is 24, and then 3 times negative 2, that's negative 6. So again, I use my order of operations. But I saw that the only operations I had are multiplication and subtraction. So I know I can go through and do all my multiplication at the same time, but I can't subtract until I've multiplied both of my terms. Okay, so now I have 24 minus negative 6. If you're wondering where I got this minus from, that's the one that I just dropped down, and then 3 times negative 2 is negative 6. Now, remember, whenever we subtract, we add the additive inverse, or we keep, change, change. So that's going to be 24 plus 6, which is 30. And that's my answer. Okay? Let's go to our next example. This one is an example where we do have an exponent. So you might want to try getting a head start on me. Okay, so again, I'm going to be looking at my order of operations. I see that I have exponents, I also have multiplication, and I have subtraction. So I have 3m squared, so that's 3 times m squared. There's my exponent and there's my multiplication, minus 4. There's my subtraction. Okay, so I'm going to plug in. So it's going to be 3 times, and I'll use the dot on this one, negative 3 squared, minus 4. Now the parentheses are not necessary here, but I just included them because I know that the first thing I have to do is solve my exponent. So just to keep things in order, I put a parentheses around this because I know that negative 3 squared is the same thing as negative 3 times negative 3. So now I have 3 times the quantity, negative 3 times negative 3. Negative 3 times negative 3 is actually just 9, positive 9. So my exponent is done. Now I'm going to multiply. 3 times 9 is 27. Now I'm going to subtract. 27 minus 4 is 23. So my final answer is 23. Okay? Let's go to our next example. Now here's a situation where evaluating algebraic expressions is actually very useful. When you travel around the world, you know, other countries, they don't necessarily use Fahrenheit like we do. They use a temperature measure of Celsius. So there's a temperature difference in Celsius versus Fahrenheit. So the formula for rewriting a Fahrenheit temperature as a Celsius temperature is 5 times the quantity of Fahrenheit minus 32 over 9. So in other words, whenever you travel the world, what we might consider to be 77 degrees, you know, elsewhere they might say that's 25 degrees Celsius. Okay, so how do we get to that? So in this formula here, F equals the temperature in degrees Fahrenheit. We want to find the Celsius equivalent of 77 degrees Fahrenheit. So we know that Celsius is equal to 5 times the quantity of Fahrenheit minus 32, all divided by 9. And we know in this case we're trying to figure out, well, if Fahrenheit equals 77 degrees. So in this case, I do have a variable that's unknown that I don't have a number for, but I do have the expression that will tell me what it's equal to. So all I have to do is take this 77 and plug it in right there. Okay? So Celsius is going to equal to 5 times the quantity of 77 minus 32, all divided by 9. So I'm going to have Celsius is equal to 5 times, well, 77 minus 32. So now I have to think again, order of operations. And I see a lot of things happening. I see parentheses. I see multiplication. I see division. I see subtraction. But the subtraction is within the parentheses. So I'm actually going to cross that out because we don't have to think about it yet. I'm going to do parentheses, multiply, and then divide. Okay? So 77 minus 32 is 45. So I have completed my parentheses. Now let me multiply. 5 times 45 is 225. And 225 divided by 9, to get rid of that division, that's actually going to be 25 degrees. So in other words, 25 degrees Celsius is the same thing as 77 degrees Fahrenheit. So a nice warm day would be considered 25 degrees Celsius. All right, let's go to one last example before we get to our problem of the day. Here's a word problem. Leah has already read 20 pages of a book. She plans to read 5 pages each day from now on. Write an expression that represents the total number of pages she will have read in D days. Okay, so we know a few things in this situation. First thing, we're trying to write an algebraic expression. That's what we're trying to do. But let's think about the things that we are given, the information that we are given. We are given that she reads 20 pages already. So she's already read 20 pages already. Alright, I'm going to rewrite that because that came out kind of messy. But we know that there are already read 20 pages here that Leah has already read. Okay, so 20 is equal to the number of pages already read. Now, we know a couple of other things. We know that that D is equal to the number of days that she will read, and we know that 5 pages will be read in each of those days, so per day. So I know if she reads 1 day, she's read 5 pages. If she reads 2 days, she's read 10 pages. If she reads 4 days, that's going to be 4 times 5, so that's 20. So if I want to write an algebraic expression for this, that means if I want to know the total number of pages, the total number of pages is going to be, so I'm going to write this over here, the total is going to be equal to the number read already plus the new pages that she reads. Well, in this situation, we know she's read 20 pages already, and the new pages, well, that's going to be 5 pages per day. So per is a multiplication situation, so that's going to be 20 plus 5D. So the expression 20 plus 5D is going to represent the total number of pages that Leah will have read after D days. After D days. Now, if I were asked the question, will Leah have read more than 60 pages in 7 days, I can now use my expression 20 plus 5D to figure that out. Because I know they're saying, well, what if D equals 7? Are the total pages going to be equal to 60 or more? Well, let's see. 20 plus 5 times 7, that's 20 plus 35, which equals 55. So the answer to this question is no, she will not have read more than 60 pages in 7 days. She'd have to read one more day, okay, to have gotten to the 60, and 2 more days to have gotten past the 60. All right, so let's go to our problem of the day. In these 3 expressions, there are 3 different variables represented. In the first one, you just have n and m. The second one, you have r and p, so that's 4 variables, sorry. But then in number 3, you have p, m, and n. So the setup gives you what each of these variables equals to, but you're not going to need to use each of these for each one of the expressions. All right? So this is the first thing that we'll go through tomorrow morning when we get to class. And good luck. We'll see you tomorrow.